Okay, so we got a pretty straightforward problem. It says one of the many uses of the scalar product is to find the angle between two given vectors. Find the angle between vectors b, which is 1, 2, 4, and c, which is 4, 2, 1, by evaluating their scalar product. So the dot product, in this case we're dotting vector b and vector c, is equal to the magnitude of b times the magnitude of c times cosine of the angle between them. Well, we want to know the angle between them, so just doing a little bit of algebra, we can divide both sides by the magnitude of b, the magnitude of c, and take cosine inverse of both sides. And this expression, that's a really ugly theta, and this expression will tell us theta. Now, how do we actually compute this? Let's start by computing vector b dotted c. Well, we just have to multiply the like components. So this is 1, 2, 4, dotted with 4, 2, 1. So that's 1 times 4 plus 2 times 2 plus 4 times 1. So we multiply the like components and then we add it all up together. So that's 4 plus 4 plus 4, which is 16. Now, what's the magnitude of b? Make this a little nicer. The magnitude of b, well, we actually just somewhat proved this in the last video, which is worth checking out if you haven't. The magnitude of v is just the square root of 1 squared plus 2 squared plus 4 squared. And what we showed in the last video, what we actually proved, is that r squared is equal to x squared plus y squared plus z squared, or r is just the square root of x squared plus y squared plus z squared. Also, I'm pretty sure I've covered this in previous videos, if you've looked at the lecture notes that go along with the mechanics section. So the magnitude of b is the square root of 1 plus 4 plus 4. 16. Which means the magnitude of b is equal to the square root of 20, it looks like. 21. And we can do the same process, finding the magnitude of c. It's the square root of 4 squared plus 2 squared plus 1 squared. It's the exact same numbers, so the magnitude is the square root of 21. Good night. So, I don't think so. I don't think so. So that's cosine inverse, that was my sister, sorry, of the dot product, which the dot product we computed to be 16, over the square root of 21 times the square root of 21, which is just cosine inverse of 16 over 21. I'm sorry, this isn't 16, this is 12. My bad. Guess I saw an extra 4 there. 4 plus 4 plus 4 is 12, not 16. Okay. Everything else seems to match up with the notes, so that's our theta. And if you were to plug this in, you should get 55.15 degrees. So this is the angle between vector b and vector c. So a bit of an easy one, but it does help us review some of the product or some of the rules with our dot product. So.